Hello and welcome to this video about Python for data handling. We are excited to have you here, and in this video lecture you will learn about the tuple, which is a Python native data storage abstraction, or you could say native Python data structure. The tuple provides us with the option to economically store labels and objects that are fixed and not intended to be changed. As tuples are defined to not be changed, their properties are easy to predict, and therefore tuples are faster than many other Python data structures. Tuples are important to know for data handling purposes, as tuples are used in a lot of older data science and machine learning applications, programs, libraries, and code, plus are a very common return type for Python libraries. Let's talk some about Python tuples in detail. So now we're going to talk about Python tuples. And tuples are considered to be another type of Python set, mainly used in older Python data science code as a tool for optimizations, speed enhancements for code, and to some degree as a still preferred return object for some important libraries functions. In this video, we include a deep dive into tuples, mainly because a lot of machine learning code, libraries, and in particular older machine learning code may use tuples for optimizations and other tuple properties. And this increases the chance, or rather makes it almost certain, that any data scientist or machine learning engineer will encounter tuples in their code or libraries sooner or later. The properties of the Python tuples are that the contents of a tuple are ordered, or you could say indexable, and unchangeable, or as you could say immutable. This means that the new items cannot be added to a tuple once it is created, and that the object items inside the tuple cannot be changed or replaced except through a process of conversion, where the tuple is changed or copied into another object type, and the items are replaced, and the result is changed again into a new tuple, possibly with the same name. If the item objects inside a tuple is of a changeable type and must be changed, they need to be copied in a similar process, changed, and converted back to a tuple object. Structurally, tuples can be considered to be sequences of object items or as unchangeable lists, or you could say arrays with different properties and capabilities than Python's native lists. And we can say that Python tuples are fast and predictable due to these properties. And Python creates a tuple through the use of parentheses enclosing items within the tuple. And you can see some example code on the screen, but now it is time to type some code. So let's open your code editors. And we will open the Jupyter Labs notebook and type some tuple code. All right, having started our code editors, we will start to type some tuple code. So we will type Python tuples. And we will begin by creating some tuples. And here we will show some issues with the tuple. So the first tuple we will create will not be a tuple at all, but something that looks like a tuple but doesn't function as a tuple and is created as a different object than a tuple. So we will type tuple 1 equals 1, 2, 3, 4, 5. And we can say that this will return an error if a tuple is expected. So we can print this not a tuple, and we can print the type of this not a tuple. So let's run this code. And here we can see that we created an integer and not a tuple with this code. So now we'll change this code to proper tuple code. So we type tuple1 equals 1, 2, 3, 4, 5 and 1. And we will print this tuple, and we will print the type of this tuple. So let's run this code. And here we can see that we have created a proper tuple. Now we will create more tuples. So we will create tuple2, and we will set it to 2 strings, hello and world. We will create tuple3, and we will set it to a string, hello, and we will create some integers and a world string. And this displays that the tuples can hold arbitrary Python objects. And we will create tuple4, and we will let it contain some integers and some floats. So we have created a tuple with some integers and some floats. And now we will type some code that shows that we can add these tuples together, for example, within a print instruction. We can print tuple2 plus tuple3, and we can print tuple1 plus tuple4. So let's run this code. And here we can see that we added tuple2 to tuple3, and we added tuple1 to tuple4. And now we will create some nested tuples. And nested tuples are tuples within tuples. We type create nested tuples, or you could say tuples within tuples. And we can also say that we can create tuples including, for example, named and declared integers, floats, etc. We type float1 equals 3.91, integer 1 equals 9, and we can set tuple5 to be equal to float1 integer 1 and a nested tuple hello world. And we can print tuple5. So let's run this code. And here we can see that the values of these declared floats and integers were printed, plus the nested tuple. And here we can take a look at how to access the elements of a complex tuple, such as tuple 5. So we can begin to type print tuple 5, and the first element of it. And we can continue with this notation. And we can print every element in the tuple. And we can show you how to access the nested tuple. So this line will access the second element of the nested tuple. So let's run this code. And here we can see that the first element, float 1, is 3.91. The second element is integer 1. It is 9. The third element, which we point at with E2, is the nested tuple hello world. And when we add another bracket like this, we can access the second element of the nested tuple. And in this case, this is the string world. And as you can see, this is very useful when it comes to handling tuples. And we can build some more on this knowledge. So we can say that we can access the contents of a tuple by referring to the order of the items inside the tuple, indexed from 0 to the number of items minus 1. So for example, we can take tuple 3 and refer to the first element, and we can print tuple 3 and refer to the third element. And here we have tuple 3's first element and the last element, or the third element. So let's run this code. And here we can see hello and world. Now we will use some advanced functions on our tuples. And we can say that if you feel that this part of the video lecture is tough, complete the Python for data handling section or video course and return to this part afterwards. If this part still feels tough, repeat the course once more and return. And you will feel that with this repetition, this code and this complexity has suddenly become very easy for you, and you will understand this code easily, and everything will be clear with some repetition. So, all right. Let's begin with some native functions which are pre-programmed into Python. And we will begin with the length function. Or you could say method for tuples. So we type print the length of, for example, tuple 2. and we can print the length of tuple 4. And what this function returns is an integer, which will tell us how many items are included inside these referred tuples. So let's run this code. And the printed numbers are 2 and 4, the number of items inside the referred tuples. And we can access the content of tuples as ranges within the tuples using a particular operator. So we can type tuples can be accessed as ranges using the operator. We type, for example, tuple 4 and this code should access the first two elements of tuple 4. And these are 1 and 4. So let's run this code. And here we can see that we have 1 and 4. And we can use loops to loop tuples. We can type 4 items in tuple 4, print items. So let's run this code. And here we can see that for each and every item in tuple 4, we printed that item. So we have 1, 4, 2.73, and 3.1. We can use the index positions of a tuple and use the length function and loops. We can type for position in range of the length of, for example, tuple 3. We can print position plus like this. And pos will be a counter variable between 0 and the range of the length of tuple 3. So the first instruction here will print that integer number, and the second here will print the content of tuple 3 at that position. So let's run this code. And here we can see that at position 0 we have the string hello. At position 1 we have the integer 1, 2, 3, 4, 5. And at the position 2 we have the string world. And now we'll take a look at tuple returns from functions and library functions. And we can say that These returns is one of the main occurrences of tuples in current Python libraries. And the unchangeable property of tuples is one of the main reasons for using tuples as a return item from a function or library. And the secondary reason is the tuples design and predictable size address location, which makes these returns very easy to handle in RAM memory. So we will type tuple returns from functions and library functions is one of the main occurrences of tuples in current Python libraries. Two reasons: unchangeability and design and predictable size address location. Let's take a look at tuple unpacking. Because these tuples, when you receive them as returns, will be, you could say, packed as tuples. And therefore, we will take a look at unpacking these tuples, which is about making proper variables from a tuple. Something which often will be necessary when you consider returns from libraries. So we can type, for example, float 2, integer 2, tuple 6 equals tuple 5. And we can print string float 2 plus a white space plus string integer 2 plus white space plus string tuple 6. So here we will take tuple 5 and unpack it into float 2, integer 2, and tuple 6. And tuple 5 is this nested tuple, which has a float, an integer, and a tuple. So let's run this code. And here you can see that we have unpacked it into the float, an integer, and this tuple. And what we will do now is that we will continue the unpacking further. So we will create string 1, string 2 from tuple 6. And we will print string 1 plus white space plus string 2. And as we have strings, we have no need to cast strings into strings. So let's run this code. And here we can see that we printed the string hello, a white space, and the string world. So here we can see that we have completed the unpacking of these already existing tuples. So what we'll do now is that we will show a custom statistics function with multiple returns. And we will say that Python, as a standard, when you have multiple returns, will always, in its functions, return the returns as a tuple. So this is a pre-programmed standard. So right, let's show a custom short statistics function with multiple returns. We type define descriptive stats from data, and we can import a library. So we type from statistics import mean, median, and standard deviations. So what we do now is that we make a sort of proper import from the statistics library, because we will borrow some functionality for this custom statistics function in order to display these multiple returns and how they are unpacked. So we type average equals mean data. We type med equals median data. We type standard deviation equals standard deviation of the data. And we return the average, the med, and the standard deviation. What we will do now is that we will print the return of this function. So we will call the function, and we will give it tuple 4. So let's run this code. And here we can see that the function took the data in tuple 4, which we served it, and it returned the average of the data, the median of the data, and the standard deviation of the data. And it returned it as a tuple. So what we will do now is that we will unpack the tuple return. We will type mean, med, standard deviation equals descriptive statistics of tuple 4. And we will print the mean plus white space plus the median plus some white space plus the standard deviation. So let's run this code. And here we can see that the return tuple has been properly unpacked. So all right, now we have learned some deep, practical, and very useful knowledge on how to use tuples. And in the next video, we will teach you even more. And we look forward to see you in the next video.